Hi everyone, and welcome to this session. Today I'm gonna introduce the building Terraform intelligent experience in Azure Copilot. I'm Yun from Microsoft Azure Terraform team. So I think this session will be very beneficial if you plan to use our service or if you want to build similar generating experience on your own. This can help you to find intuition and help you come up with this solution. And feel free to share any questions if you have in the chat, and I will have a bit longer and answer your questions. Okay, so let's get started. Okay, in this session, there are four parts. So the first section includes Terraform Handler for Microsoft Copilot, which focus on how Terraform Handler is built and how to use this. We focus on the speed and efficiency. And after that, I will talk about GitHub Copilot Chat extension, where we have a Terraform plugin. I'm going to give you a quick demo of this and show you how to use this. After that, we will talk about the evaluation framework, which is very essential. It helps us to keep our generation quality to the best stage. And I will show you the improvement we make. And lastly, we will discuss our future plans about how we provide more ability and have better user experience. So no more waiting, let's get started. The first part is Terraform Handler for Microsoft Copilot. So this experience is tied with Azure Portal, and currently it's in public review stage. So if you have an Azure account and if you have access to a Copilot in Portal, I encourage you to try this out yourself as well, and let us know your feedback once you have used our service. Okay, so I can have a quick demo here. So, okay, so here is our Azure portal. And in the top right corner, you can see there's a Copilot button here. Once you click this, you will see the Copilot blade, right? So in this blade, you can type in any Azure-related questions, but if you have a Terraform-related one, like I have here, you can type in the chat window and click Send. So here I ask a question to help me create a Terraform template to build an open endpoint using a specific model with a specific version. Uh, we can see the generated result is coming. Okay, great. We can copy this because this code block is small. So we copy this and paste it into a VS Code extension. And we can see this one. And oh, sorry, I need to redo this. Sorry. Okay. We can. So if you have a Terraform related question, just type in like I did here. You can see that it determines what to do, and it's generating Terraform template. It has different stages of generation, and it will have a final result once the generation is complete. Okay, so here's our final generated result. You can see we render the HCL language, and here's the full result. Like I said, I can copy and paste this into the VS Code, and we can do a quick go through of this generated content. First of all, it will help you to create a resource group, and then a cognitive account, and then a cognitive deployment. So we can see that we specific model version and a model name. So it also follows the instructions to do this. I already built an Terraform the environment here, so we can run Terraform validation to make sure we have a valid template. Terraform validate. Okay. Let's wait some time and wait for the validate to complete. Okay, it returns as success, which means that our generated template is good. That's how to use our service. Okay, let me go back to the slide. And okay, let's go to the next slide. So here in this slide, I talk about the high-level data flow. So how does this happen behind the scene? Um, so um, First of all, when user types in a question like I just did, um, it will format a conversation history. So it can have multiple conversations. So when you talk about other stuffs, it will also have a conversation history. So after that, that conversation history will go to the portal orchestrator, and the portal orchestrator will select which handler to use when they um, see the conversation history. So they will analyze the conversation history based on user's intent and to select which handler. So if I ask a question about Terraform, it will select the Terraform handler. Okay, so once the Terraform handler is selected, we will go through a series of steps to generate high quality speed. And after that, the generate result will return to Portal Orchestrator, and it will help to display this generated content into the Copilot blade. So this is the data flow process. Okay, before we go into the detail of how the Terraform handler is generated today, our talk I will just focus on the Terraform handler. And so before I go into the details, I want to say that there's two key factors and two challenges we faced about this task. The first one is generating high quality content. So the primary focus of AI generated content is always its quality. So during our interview with our customers, we can say that the customers always want high quality generated results, right? So the second one is speed. Um, so long waiting time will cause user to become impatient very quickly. So we need to strike a balance between maintain high quality and speed. So I'm gonna show you the steps and tell you how we did this. Okay, so the first step is when we receive the conversation history from the portal orchestrator. So our handler do is enter a filter and browse step. So in this step, we ask LLM to see, okay, so please tell me whether this question is a valid Terraform related question. If it is not, I will just throw it out to Portal Orchestrator to tell it that, okay, this question is not Terraform related. Please pick a different handler for this. So if this question is in scope and we think, okay, this is a Terraform related question, then it will enter the input rewrite stage. Um, so for all the in-scope questions, we will rewrite this query. We will have LLM to identify what the key resources in this query is, and to rewrite this query in a clear way. This is very important, and we can show why this is important in later steps. Then we enter step 2. In step 1, we have the question summary and key resources definition, and then we use these question summaries to search in an pre-built AI search knowledge index. We use vector search and hybrid search we use hybrid search, including a vector search to do the search query. So after the search query, we will retrieve the relevant documentations and resource examples. But we will do another selection based on the retrieved results. So how do we do this selection? We take the key resources we just retrieved from the first step, and we will ask LLM. So here's the key resources. Here's our analyzed user's intent, and here are some possible related resource names. And please help us to select for example, the top five most relevant resources you might you think, and it will help us to reselect the relevant documentations and resource samples. After this, we will take these reselect results into the next step. So you can see in the right, there's an independent step called index update. Actually, this is for the retrieval process to be as fresh as possible, because when we build the AI search index, it has a cutoff date. So we have to regularly update the AI search index to make sure that it documents align with our latest documents in Terraform. So it doesn't contain any um, knowledge. So here's the index update step. After this step, so in the classic RAG steps, these steps takes in and retrieval step. After this step, we will go into the generation steps. Okay, so here is the generation steps and the validation loopback. So in the generation steps, um, we will first take the relevant documents and resource samples we just retrieved and add this into a meta prompt template. So in that meta prompt template, we will have detailed instructions to tell LLM to how to generate this and what rules you should follow. And we will also enrich this with the relevant documentations and resource samples. And after that, we will do the first round of generation. We will do the first round of generation here. Sorry, this, okay. So after that, we will do the first round of generation by calling the LLM bond to generate the result. So after we retrieve the first result, we will go into the validation step. So actually here we use Terraform validation to collect the error messages. For example, if the first generated results contains some resources that does not exist, contains some properties that should not be here, the Terraform validation will tell us how this error message is and in which the generated content, in which line, in which column this error message appears. After that, we will take this error message and retrieve relevant documentations again. And after we have all the information, for example, we have all the error messages, we have the previous generated content, we will ask LLM to help us to fix this for us. We do this validation loop for a few times until we are satisfied with the generated results. And after that, we will return the final ultimate generated template to back to the Portal orchestrator and let it handle the render and the showing in the Copilot channel. Okay, so this is basically how we build this Terraform Handler service and how we make sure it has good speed and quality. And in the next slide, I will show you the overall design of this. So here's the overall design. You can see that we went through the chat history summary, went through the rewrite stage, route stage, rewrite stage, retrieval stage, and the generation stage, and validation loopback stage. So after all of this, uh, it will come up with the final output. And this final output will have better quality than the LLM native call. Okay, so if you can remember, I said there are two key factors and two main challenges we face when we do this generation service. The first factor is how do we maintain a high quality generating service. And I think the key factor I mentioned here is use the correct model or the better model. Before we used GPT-4 series, we actually have a version that used GPT 3.5 Turbo. um, that model has less ability than the GPT-4 series. So I found that no matter how I do the prompt engineering, no matter how I try to um, give it the right retrieval documents, no matter how hard you do, you cannot surpass the beta model. When we switch to the GPT-4 mini model, the result is absolutely better. I can show you after I introduce the evaluation pipeline how the performance and quality is improving. All right, so the second step is we want to enhance the throughput because we are online service. You always want to enhance your throughput to satisfy more users. So we implement an async workflow to make sure that none of this pending. For example, if a service is if a pending when a user is pending a retrieval of an OpenAI service call, so the other users won't depend on this. Okay, so the third one is we actually get this idea from the React framework. So when you use validation loopback, when you react to the error message, because we use Terraform validation, so if you we have to create folders. If you do this when you need this, it will slow down the generation time. So we use a pool during startup. So we preview this, preview a series of folders to make sure that these folders are ready to go. And when user validate Terraform templates, it can quickly run and get results. And when user finish using this, we actually put this pool um, in a cleanup stage and put it back for ready to use stage. So the next user will have to wait for the folder to be ready. Okay, this also help us with the speed. So the final way, the final I want to see is that the validation. So the validation loopback really help us to improve our quality. Because asking the LLM to generate all the resources, all the properties in one time and in a correct way, that is very uh, that is very hard. But if LLM can autocorrect, means that if we tell the LLM where the generation content is not correct, um, and ask LLM to fix these issues, the LLM can actually help us to do this. So this also be good if you are building your own generation service. You can think of if you have a compiler or a validation service, uh, make sure to use this and use this validation loopback will definitely help you with the performance. Okay, here's the first part, and I'm gonna introduce the second part is the plugin for GitHub Copilot Chat extension. So after we launched this Portal experience, we had an internal user review and say, hey, what's your feedback is? So some of the users actually tell us, I just, in the Portal, there's just a very small code block and it's difficult to read and it is difficult to edit. So user have to paste it into the VS Code like I did before. So we are wondering if users are using native VS Code natively, so where can we bring this experience to VS Code? So this bringing the idea of Terraform plugin for GitHub chat extension. I will because this is still in private review, so some things are subject to change definitely, and I'm gonna show you a pre-recorded demo of how we are gonna bring this experience to GitHub Copilot Chat. Okay, so here's a very classic VS Code panel. And you can see that if you click this Copilot button, also in it's the GitHub Copilot button in the top right corner, and there will be a chat window. And if you type a question after at Azure, read it right after with a Terraform related question, um, you can, like I did here, create a Terraform template. um, Also, the same question I used in the portal demo. And I asked it to create a GPT-4 mini model with a subscription version. Um, and let's wait and see how our handler, our plugin will reply. You can see that the plugin will activate it and start generating Terraform experience. And this is a streaming experience, so you don't have to wait all the result to be complete to see the result. Okay, so you can see there's already generated content in the right side. There's copy paste button, of course. You can copy paste directly into VS Code. And we also validate this using Terraform validation to make sure, okay, this generated content is a valid Terraform template. Okay, so this validation is success. Okay, great. So here's our GitHub experience will be, and um, I encourage you to use it once we launch it. Okay. Um, so next, I want to talk about our evaluation framework because our evaluation framework is essential for making sure um, we are releasing a high quality service. So in the evaluation framework, we use the evaluation score to access the quality of generated results. So it mainly measures four components. So the first one is HCL syntax. It will make sure that the whether the generated content follows the HCL syntax parser requirements. The second one is because we are generating using Azure RM provider, so we will validate the Azure RM syntax as well. So the third one is relevance. So we will validate whether the generated content is relevant with the user input. You can, so if a generator can generate questions that passes the HCL syntax check and Azure ARM syntax check, but it's completely has no relevance with the user's input, that will be a bad generator, right? So we measure the relevance. We also measure the correctness. So we will break this um, into we will use ALM to measure the similarity between the purpose and relevant sections. So we will actually break the user intent into several steps and check whether this step is fulfilled. Whether this step is fulfilled. If it's not fulfilled, it will get a low score. So after we evaluate these four parts, we will combine them together with a final score. We have an algorithm to do that to summarize these four scores into one score from 0 to 100. 0 is the worst, 100 is the best. So I can show you the approaches we take before to enhance speed and quality. So how these approaches affect the final evaluation score. You can see that if we use GPT 3.5 Turbo natively, it will just have an evaluation score of 61. But with the change of model, with the customized RAG logic, like I said, with customize the retrieval process, and with the validation loopback, we ask the LM to auto-fix. With the intention analysis, if you remember, in the rewrite stage, we will also rewrite the user's query to make sure that it reflects and reflects the user's intent in a clear way. With all this, our evaluation score reaches 86, which is all-time high. So we also have a plan to make sure that our evaluation score exceeded 90 in the future if we are trying to do this. And if we approach, for example, have better models, if we have more detailed analysis of users' input, and we are trying all kinds of stuff to make this happen in the future. Okay, since we talk about future, I also want to mention a few future works to enhance speed and quality and of course user experience when user use our service. The first one I will talk about is the context awareness. So one of the feedbacks I receive a lot when we talk about this is user want to say that, hey, I already logged into Azure and you are a service at Azure Portal, so why can't you access my existing infrastructure and give me a, for example, follow the name pattern I have in the existing infrastructure. Because for some privacy reasons, we haven't got that info so far, but we are trying to do this in the future. So make our handler uh, contact awareness. And the second one I'm talking about is direct editing. So you can see that when I do the demo in the portal, so there's a small code block, so and it is not very easy to see. Um, so we want user to have this experience that you can direct edit the generated content in the portal UI. The third I want to talk about is more providers, of course. Currently, we support Azure RM provider. If you use Azure, that will be good. That's the um, provider we want to use. But also, we want to support more providers, for example, EVM and AZ API providers in the future. Okay, uh, that will I have talked about the experience in Azure and how we build this. I also talk about how we bring this experience in the VS Code extension and our future plans. Um, and that will be all. And that will be all of my talk. And I'm happy if you have any questions, and I'll count a bit later, and to help you answer them.